If I could ask you to clarify what an acoustic imager is and how it works and what it can be used for.
Okay, well, an acoustic imager is a device by Fluke, and what it's doing, it's listening to specific signatures of frequency. That is received by these 64 sound microphones here, as you see, and the sound obviously reverberates from a system that's under pressure. What that leak would potentially do, as it's broken, is it would disturb the air from where that leak is, and this is able to listen to that specific signature, receive it, and then visually map it on a touchscreen, LCD screen for the user to simplify where it is and help position where that leak is taking place from.
And is that ultrasonic?
It is ultrasonic, yes. Yeah. On this device, it listens obviously outside and within inside the human hearing range, so it's going from 2 to 50 kilohertz and from 2 to 100 kilohertz, whether it's the ii900 or the ii910. So it's listening to that sound at higher frequency, and it's obviously able to then pinpoint it using a selectable range on the back of the device to help filter out any unwanted noise, and that helps you to pinpoint the leak very simplistically.
So it's quick, it's easy.
Yes.
Yeah. Okay, so we'll talk about the applications and advantages in a minute, but first, could you clarify the differences between the ii900 and the ii910?
Sure. Okay. Well, the primary difference is what I just spoke about a second ago, is the frequency range. The ii900 is the entry-level model that we have, and that is able to do leak detection, as I say, from 2 to 52 kilohertz. That there is able to just pinpoint any air leaks under pressure, and depending on the gases, some are obviously more challenging than others, depending on the density of the gas. But if it's just a typical air leak with compressed air, this device will pick it up very quickly and efficiently. So that's the ii900. If it's the ii910, it's able to go to a wider frequency range, so it goes from 2 to 100 kilohertz, which opens it up for more applications, and it's a more sensitive device than the ii900. So that's the air leak side of things. On top of that, the ii910 has additional functionality as well. The main one being here is we offer leak Q, PDQ, and METQ now is our latest feature that we've introduced for this. The PDQ stands for partial discharge quantification, and the METQ stands for mechanical quantification. These are all different signatures and different ways of analysing set parameters, and this will do this for you quite straightforward and simply by giving lots of visual information on the screen for the user to obviously report out to anybody that needs to have that information.
So partial discharge would be like electrical high voltage sort of applications. What would METQ be for? Is that what's that for?
Yeah, no, you're there pretty much. Yes, it is. It's ideally targeting bearings specifically. What's happened over the last few years is that we've seen more and more requirement, if you like, for bearings and motor analysis. And what's happened is the signatures that we've seen have now, with liaising with various partners, have given us information so that we now know that set frequencies allow us to pinpoint potential dangers or failures that could potentially happen at set frequencies. So with the ii910, it has a number of different functions that are able to help the user detect potential bearing failures down the line and obviously improve preventative maintenance for that aspect.
And just on the air leak detection, you say it's got a wider frequency range, so does it detect more gases? So is it better for like the lighter gases that you mentioned the ii900 might struggle a little bit with?
It doesn't work exactly like that. What it's for, it's just a wider range basically, because obviously it's all about the resonant frequency of what these are. So with the ii900, it has the ability to go higher than that. Now, most leaks in most compressed systems will take place around about 25 to 35 kilohertz. That's what the ii900 is specialist for. The ii910 takes that count higher because of the additional features. So it doesn't just look at leak Q. It then would add the PDQ, which again could potentially happen at higher frequencies. Therefore, it doesn't have the functionality in the 900, and you'd have to then move towards the ii910.
Right, okay, I see.
Sure.
And so to whom would you recommend these acoustic cameras? Who would benefit most from implementing them?
Well, again, depending on the model, but overall, we aim these specifically really around certain personas like maintenance engineers, energy efficiency engineers, and just general overall, well, we call them cost reduction engineers as well, because these are all aimed at saving time, saving money. So for leak detection, you've got your maintenance guy. He could have leaks he doesn't know about on the site, and it just allows him to go and pinpoint these accurately and quickly, and then obviously decide to put them in a preventative maintenance plan to fix them in maybe a program downtime or shutdown they might have. When you start looking at PDQ, this is obviously an area that's very vogue towards the electrical utility industry. So again, where there's high transformers and overhead towers that need to be obviously measured and maintained, that works perfectly as well. And then the MET-Q, well, again, that's maintenance and facilities. And it's just looking obviously at keeping the flow of plant running safely and efficiently. So all the devices apply to lots of different personas, but it all focuses on cost reduction and making the plant run more efficiently.
So are we talking sort of factories, you say plants, like utility plants and things like that? So is that sort of setting that we're talking about?
Okay. Well, the nature of these products is that they almost apply to every industry. We know now that almost around about 70% of all plants, all manufacturing processes have compressed air systems on site in some way, shape or form, whether it's from packaging, through moving equipment through the site, whether it's through part of the building and process that they might have, whether it's a clean lab where they're using air filtration. There's lots of different applications. I've taken this unit into companies from the military through to food processing, to beverages, to chemical plants, for argument's sake. So there's almost every site you go to does have an application. It's just about obviously giving the education to people and knowing how they can obviously save some money with the device.
What about hospitals? Because they use like medical gases, don't they, in systems?
Sure. Again, hospitals is a very one as well, because again, they use lots of compressed air, obviously, around the facility. They've got air conditioning systems as well. They want to make sure it's tight. They may even have cooling parts as well, where they need to obviously keep the hospital running. Some of them even have cooling sections as well. So yeah, hospitals is a very, very appropriate one to go and take the equipment into. But yeah, like I say, there's not really an industry that the product can't be used in, to be honest with you.
So why would you recommend the Fluke acoustic cameras to these sectors? Like, how can organisations and businesses benefit from using them?
Okay. Well, the reason that Fluke actually brought this unit to market was because there was a massive gap there on traditional methods, like you've just mentioned. Traditionally, people may have used something almost as basic as soap or water to go and try and find leaks, because what happens is a plant that's producing equipment and they see a drop in pressure. They obviously know they've got a leak there. They don't know where the leak is. They've got to then obviously go and investigate it. And with some methods like soap and water, or unidirectional acoustic imagers, where a guy might have headphones on and listening for a signature, it's very time consuming and very laborious. So the essence of the Fluke unit is to speed up that process. You want to be able to obviously scan a large area in the shortest amount of time possible and get the readings obviously you're looking for and pinpoint those leaks. And what we've seen is that this device has obviously been well received by obviously lots and lots of people out there, because they're obviously not having to spend hours and hours looking for leaks, and even they get to the point where they go past the leak because they can't find it. With this one, they're obviously able to just visualize it. They can see the leak, and obviously they spot it from distance. They're then able, because it's a portable device, they can walk closer, they can change angles, and they can see exactly where that leak is coming from and pinpoint it very accurately.
And they can take pictures, can't they?
Yes.
So I imagine that's good for coming back to check if it's been fixed and to like maintaining in the future, because you know that's a problem point, so you can just go back.
Well, with this, yes, you're exactly right. The unit takes obviously a still image like a JPEG file, and it will also take an MP4 file as well. So should you want to do a short video and capture obviously changes, or maybe the system runs off and on, if you like, it allows you to capture that. Yes, the unit in here will take those very simplistically and visually map it on the large touchscreen display on the back. Once you've got that image, yes, you're exactly right, you can export it out into some software, which can talk about. But the mode of method that we're most interested in here is people just want to find the leak. That's great. That's what the very basic nature of this is. If people want to go one step further, they may choose to actually quantify the volume of that leak. And with the ii900 and 910, with the leak Q feature, that's able to not just find the leak, you're able to put in the pressure that leak is, the system is operating under, whether it be 1 bar, 2 bar, 7 bar, whatever that leak pressure might be, and then the type of gas. And what the unit will then do is give you a severity leak rate from 1 to 10. So it'll say, that's not a very big leak, don't be too concerned. This one here is much more severe. And when you have that, you can then get the leak rate in litres per minute. And it will also estimate a cost. So again, once you do a quick walk around of your facility or a set production line, you're then able to quantify them in a report and go, okay, the total leaks that we have on that line is X, and we want to prioritise it as let's get that one done first, then this one, then this one. And it, again, helps to bring down the cost of that leak. And
it streamlines work as well, doesn't it?
100%, 100%.
And I noticed in one of your videos for the acoustic cameras, you state that you can learn to use it in under 10 minutes. So with the traditional methods like the acoustic ultrasonic detection, you need some sort of specialist knowledge for that, but you don't so much with this one?
No, that's very good to say, very accurate. Because it's a very intuitive bit of equipment and it's visual, obviously everybody likes the visual nature of it. You know, you see a blank, just a normal digital photograph, then all of a sudden a leak pops up on screen. It is almost as simple as that. We would have to give some basic training as to how to position the sliding scale for the frequency range, but in principle, yes, it is that simple. And what that's done then, it's taken away the skill, as you rightly said, from previous engineers. Listening for acoustic signatures with a unidirectional one with a headset on and trying to obviously define what that leak is and where it's potentially come from. That's a bit of a trained art, if you like, as well. You do have to have a lot of, well, I'm going to say a lot of experience, but you do have to have experience in knowing what you're looking for to be able to try and do that. Because the unit is so intelligent, all the algorithms inside here, and they're able to detect it and the way it does that. I'm not going to say it takes away the skill set, but it definitely means that you can pick up the unit and obviously start to make some investigation very quickly.
Yeah, just saves you time. Really.
Yeah, 100%.
Yeah. So just picking up on how businesses and organisations have used it, I've got a couple of examples of manufacturers, hospitals using the Fluke ii900. I wondered if you'd heard about these and if you could expand on either of them. So I'll just run through them for you.
Sure.
Right, so the first is a tyre manufacturer, which is actually a case study that Fluke did, I think, who used the ii900 to find steam and nitrogen leaks.
Yes.
And the leaks were costing them, you know, in regards to wasted gas, but also it meant the tyres weren't meeting standards, and they were having to pay to recycle them properly, and it's just very expensive. So they were desperate to find like a quick, simple solution that would work in a sort of noisy, dangerous environment. So they invested in an ii900, and the maintenance engineer had this to say. We were looking for a tool to easily detect the leaks and visually see the location, as this is a pain point for us. We are glad that Fluke came up with a solution which is beyond our expectations. Safety is our priority. We are working in harsh environments. Steam and high pressure is being used in various sections. Detecting the leaks easily and visually from the distance is a major advantage. The ii900 helped us perform preventative maintenance. We are able to reduce downtime by detecting the problems in advance. Do you have any more information on that, like savings?
Sure. Well, the application, I know about it because I had some involvement with writing some of the papers with this as well. So yes, I do know what you're on about. Obviously, the essence of it was that the molds of the tyres weren't being consistent enough, basically, as well. And the hydrogen was part of the cooling process for the plant. And what was happening is they were obviously getting, the pressure wasn't being applied sufficiently because they were getting leaks into this as well. And because of the environment, like you say, it was quite harsh, they had to obviously be operating from a distance where it was safe enough to do so.
Yeah.
And obviously, as you can imagine, it's a busy plant. So again, what we were able to do with the 900 series here is they were able to filter out all that background noise, because it's just classed as background noise. It's clutter. You don't want to be, you're not interested in that. What they were interested in was the things that we can't hear, so above that 20 kilohertz range. And they were able to pinpoint those leaks and help quickly identify where they were. And once they started to obviously rectify these problems as well, they found that they're obviously, I'm not going to call it failure rate, but their production's increased, if you like, as well, significantly. So yeah, it was a case of they could go out, they could do the job, they could find the leaks, and it improved obviously their efficiency as well. And obviously it was a success for them completely.
So it provides savings in multiple areas, really, didn't it?
Definitely, yes.
The other thing about the ii900, you don't need to shut the entire plant down, do you, to detect the leaks?
Yes.
So it's not like they were losing production either by trying to find these leaks.
Yeah. Again, this is one of the beauty of tools. I mean, people that may have been involved with other pieces of Fluke equipment like thermal imagers, these have always been noted as being non-intrusive tools. By that, I mean that exactly what you've said. You don't need to shut the equipment down. You want it to be in its normal operating conditions. You want it to be at maximum pressure. You want the machines to be turning at the maximum RPMs, etc. And what these do is, because you distance yourself from the equipment to help find these leaks, obviously, again, the plant runs, it's in its normal operating conditions, because that's when leaks happen. That's when failure takes place. It doesn't happen when everything's switched off and nice and quiet. So yes, to be able to step back, I mean, this unit here can go from half a metre to approximately 50 metres with the ii900, and it can go up to 100 metres with the ii910. And that just provides some good level of functionality, because not all leaks happen at ground floor level.
No.
Some could happen, but obviously a lot of factories nowadays, they place pipe work and ducting and things like this in elevated positions out the way. So again, this just means you don't need to obviously put up some high levels of ladders and other to stabilising a piece of equipment. So yeah, you can cover distances quite safely and easily. So yeah, it's a real game changer, as we like to say.
I imagine that's particularly useful for like high voltage stuff, because you don't want to get too close to that.
Oh, yeah.
So the second example I found was actually in a hospital. So it was from the Mediclinic group, and they were using the ii900 to detect gas leaks in systems bringing oxygen to patients' beds. or nitrous oxide to operating theatres. And they were looking for these leaks to improve patient safety, reduce hospital overheads, and improve sustainability. They were very pleased with the results, and I'm definitely going to butcher this name. Petrus Swain-Pole, Mediclinic's Southern Africa Sustainability Manager, explained, there is a pressing need for companies around the world to act more sustainably, and the Fluke ii900 industrial acoustic imager enabled us to do this by minimising the leakage of any medical gases and our increased use of oxygen during the pandemic. With its associated costs, focused our attention on the benefits of identifying leaks. We are delighted that the equipment has been able to make such a big difference to patient safety and to minimising wastage. Could you speak a little bit about how it can improve sustainability?
Okay. Well, what you have there is that they've got obviously these gases that are stored there, obviously in a safe environment at the hospital. The first thing they want to do is check them on a routine basis to make sure none of the seals or any of the couplings where they're filling these or whether they're obviously in a storage area, they want to check them on a routine basis. They're then obviously moving throughout the hospital to get them to certain areas of the hospital that need that equipment as well. And again, as it's going from the tank, if you like, to the patient, obviously you want to reduce any leaks along there. Because these are, I'm not going to say expensive gases, but they do have a cost that's incurred to them. You want to reduce them. It's that simple. So everything that you can do to make sure these lines are secure, the couplings, the connectors are all secure, means that what you're getting in the tank is actually what's being able to be delivered to whoever needs it. And again, these will pick up the slightest of leaks, and it just helps them obviously maintain the efficiency. The more you can retain, the less you waste. The more you don't waste, then obviously the more you can give to the patients. It's as straightforward. So
the other thing, I suppose, as well, is that some of these gases in medical settings, so particularly with, like, I know there's an example in Britain of like the gas and air for people in labour, and midwives, when they're exposed to that, that can be quite negative for them. I suppose reducing leaks in that sense protects patients, but it also protects staff.
Oh, yeah, exactly. A leak is still a leak at the end of the day, and no matter where it's leaking, it will have an impact on somebody somewhere, if you, whether it be from a cost implication or from a safety application, like you've said there as well. What you want to do is ensure the gases that are leaking are one. You want to reduce as many of them as you can, but you want to make sure that where these go to, the gas gets to where it needs to get to with no interference and no disturbance of anybody in the area as well. You mentioned hydrogen there as well. Hydrogen, again, is becoming more and more popular everywhere we go nowadays as we look to make energy savings. And again, it's not a volatile gas as such in that sort of nature, but again, it can be dangerous to some element, and with that you want to obviously be able to pinpoint any leaks and make sure it's stored safely and transported safely. So yeah, there's definite benefits.
Will have more of an impact as we move towards, like, we're trying to get rid of petrol and diesel cars, aren't we, by 2035, and the options are electric and hydrogen. So do you think checking that hydrogen is being transported safely will become more and more prevalent?
Definitely. It's not just the hydrogen as it's being transferred, if you like. So obviously you've got the trucks that carry it from point A to its destination. Then you've obviously got the transfer from vehicle to the stations, the pumps and all the events there. So there's lots of different, what we call weak spots, if you like, where you're having to join pieces together. And it's those that need to be checked and maintained as well, because again, you're buying a product, you want to receive 100% of that product. You don't want any leaks on the way, and again, you don't want it to potentially become a danger to anybody in the areas as well. So
that's a simple, effective
it's a nice, easy way of doing this as well. We've got lots of examples where we've been able to find hydrogen leaks as well.
So how do the Fluke acoustic imagers benefit the HVAC industry?
Okay, HVAC obviously is an area where you want to move heat and ventilation throughout a building efficiently. And what you find is the production of that system, if you like, might be in one location. And there's a number of ductings, if you like, that move around the building to cool every section of that building. And with that in mind, you want to look for any potential leaks. And this is a nice, easy device that can pinpoint them. So you're just looking for escapes, basically leaks in the system, and that could help pinpoint them very quickly and efficiently.
And similar question, how do the Fluke acoustic imagers benefit the electrical industry?
Okay. Electrical industry can always benefit from acoustic imaging because depending on the nature of what that job is they're doing, it's an additional tool to their arsenal. Again, an electrical engineer might be looking at anything to do with pressure. He could be putting in a pump, he could be putting in a vacuole, he could be doing anything. It could even be a motor mechanic. And anything that's under system pressure, this would help pinpoint the leak. He might do the repair, but he needs to verify that the system is still working accurately and without leak in the system as well. So that would obviously be a benefit to him.
Thank you. Sure. We've learned that the Fluke ii900 and ii910 acoustic imagers can be used to find air leaks, partial discharge and mechanical failings, potentially saving businesses a lot of money. But if I was a facilities manager or a site manager, I might say to you, we already have measures in place for detecting leaks, for example, acoustic ultrasonic leak detectors, and I only have a finite budget. So why should I invest into one of these imagers? What makes them better than the traditional methods we already have in place?
Okay. And a lot of historical ones will look at fixed sensors. Fixed sensors are obviously something would always be relevant to a company that's obviously looking for escapes, if you like. They might be ppm meters, particle meters, if you like. They're looking for changes in pressure, if you like, and looking for particulates in the air, etc., because there's leaks. So they want alarms to go off and etc. What they'll do is they'll tell you that there is an issue in a zone or in an area, but you don't know where that leak's coming from. So this is where this unit would step into its own. We go to a lot of chemical plants where they'll say, oh, if you hear this alarm, it's because a gas has escaped or a gas leak is taking place, and straight away it's quick, leave the area, get out. That's great, and obviously safety is critical. What they don't know is where that leak is taking place from, where it's actually coming from. They'll say it's in such and such section of the plant. Okay, that's good. This device then comes into its own because you can stand at a distance and obviously start to scan that area and look exactly where these leaks are coming from. Now again, it will detect a number of gases. Obviously some are easier than others depending on the density. The more dense the gas, the easier it is to detect. The lighter, the more challenging. But again, if the system's under pressure and that leak is a constant leak, this will help you pick that up there. And it is obviously a very simple, efficient, and can be done at safe distance. So obviously that's a real benefit because it is a hand tool at the end of the day. It's not fixed, it's not stuck in one place. Again, you can move it around the site and look at things from different angles. So again, it just helps you pinpoint those leaks. That's where we see a lot of obstacles being overcome because again, there's lots of chemical plants out there, lots of process plants, lots of food production and beverages, and every site we go to, there are alarms and different methods of check. But yeah, we seem to find that we're overcoming all these obstacles because of how easy to use and portable this equipment is.
Yeah, and just in terms of like cost versus savings, like obviously, I think it's fair to say that this is not the least expensive piece of equipment. Okay. But from what you're saying, I'm getting that you can reap a lot of savings with it. So sure. You will make up the investment pretty quickly. Sure.
Okay, well, what we've done is with Fluke, they offer what we call a justification, or help obviously give some estimations to how you can get a return on the investment of the unit. So you can put in some criteria into one of the pages on our website. And what that does, it says we're open for so many hours, we produce this, we do X and we do Y, and it will help you criteria that. But what we've found from experience is that people know the cost of the device up front. When they start to look for potential solutions to their problems, they'll look on websites, they'll look obviously for information, and they come across this and go, oh, we've not tried that, we've not seen that, and they're not put off by the price because they know the price up front. Then when we're able to get to site, and I've done this on many occasions where you go to a site and you just say, okay, see if you can find me a leak, and we just step from the office into the environment, if you like, or onto the plant floor, shop floor, and I go, there's a leak there. And it is literally as crazy as that. Sometimes they're going, oh, my plant is perfect, etc., in so many funny ways. And then you go and go, there's a leak there, and there's a leak there. And I go, can we go over to it? Yes. We take an image and we'll say, okay, that leak has cost you X £100. Oh, we didn't even know it was there. So by the time you've done that 3 or 4 times, they suddenly start to appreciate, obviously, the return they're going to get from this piece of equipment, because that leak could have been there for 10 years for all they know. And they've done nothing about it. So yes, it's designed to obviously find the leaks, but then we also have the reverse of that. We go to sites where they go, well, we found no leaks. Well, isn't that good? That's what you want. You want your site to obviously have no leaks, but we know that we'll find leaks anyway. But it's a way of not just finding the leak, but fixing the problem, and then going back a day later or a week later and then checking again to make sure that leak is no longer there. The system is tight, and then obviously those costs do start to reduce over a period of time. So there's benefits all around here.
I suppose, as you were saying earlier, it allows you to prioritise which leaks you need to address first, which means that you're not spending money needlessly on fixing things that aren't so much of a problem yet.
Yes, I mean, we found it where these products, obviously, because of, as you rightly say, the cost of them, some people have gone down to obviously having this as a business case, if you like, and they would add it on to other inspections they do. But what happens is they check the plant today, they'll find a few leaks, and then what happens, another leak takes place the next day because they've fixed this one, the problem just moves further down the line, or it creates another problem. So that's why we're finding the larger the plant, the more easy it is to provide the justification. But I've been to the smallest of businesses where it's critical for them to do certain things, and one saving here could save thousands for them in production. So it's not just finding a leak, it's ensuring that what they do and how they manage them products and produce them over a period of time, given that level of consistency and accuracy as well. So yeah, it's not just finding leaks, it's making sure the plant stays efficient and running correctly as well.
Yeah. Right, so you mentioned on-site demos. Could you just talk us through what that involves, please?
Well, we obviously get asked to do demonstrations by customers because they're investing a reasonable sum of money, if you like, to obviously take this kit on board. But I've got to be honest, from my years of being in test and measurement, I just like getting out and doing the demonstration. So any opportunity we get to go and do a demonstration at the customer's location is the perfect scenario, because we're not able to just visually show the equipment to the customer on his own applications and show him where his potential problems are. We're actually able, because it's an intuitive bit of kit, we can actually get it into his hands and let him find some of his own leaks, and it gives them the confidence that even obviously post-sale, they're able to use the equipment with confidence, and obviously they've got the experience, and we can obviously help them along that journey. But to do any demonstration, it's always best to let the customer see it for themselves on their own site, own plant, finding and helping fix their own solutions.
And how can they organise a demonstration?
Okay, well, obviously to reach out to Fluke directly, or to obviously our channel partners like yourself, that's always great. And then we're here obviously to help and support you. We're working in harmony with you guys, and that's what we want to do. So anytime you have an opportunity get to a customer's site, we welcome the opportunity to support you with that and ensure that obviously the customer and yourselves comes to the beneficial end for everybody.
Great. So we've talked about how sophisticated these pieces of equipment are, but we've also mentioned that they're also simple to use. However, there are a few features and capabilities that I'd like a bit more clarification on.
Okay.
So please, could you explain the significance of the arrangement of the 64 microphones?
Well, the 64 microphones came about because the company that makes the actual array that we're obviously a part of the Fluke business now, they did obviously years of investigation to find out the optimum way of receiving this sound through these microphones to visually map it. Obviously, we tried different formations, different patterns, increased, decreased numbers, and we just found that over obviously a lot of experimentation, 64 was deemed the most optimum. You can obviously put more on there, but it's not actually going to improve the way in which the sound is received, and it won't map it any better. The sound obviously is just received through these microphones, and then with the clever algorithms inside the unit, it's able to visually map it, and there was just no benefit to having any more. So the way it's all patterned here, it's beyond my knowledge, but some clever people out there have obviously worked on this, and again, after lots and lots of experimentation, this was proved the optimum one for this device. So that's what we stand with.
Great. What is the advantage of having an adjustable frequency setting?
Okay, the two ranges that I mentioned earlier, on the 900 goes from 2 to 52 kilohertz, and on the 910 it goes all the way up to 100 kilohertz. What happens between that is that if you were to have that as a very wide band, you could get obviously a lot of clutter, if you like, in there as well. Now, especially at the low end frequency, where you look at 20 kilohertz and below, that again would hear us talking, if you like, as well. So what you're trying to do is look for finite signatures. From it, through experience, again, we find that most leaks of compressed air take place, as I mentioned earlier, between 25 and 35 kilohertz. Obviously, that's not definitive, and different pressures, different applications, different gases even, can mean that you might need to increase or decrease that. So what we have is we have a sliding bar on the side that you can move up and down the frequency, and also you can adjust its span as well. So you can narrow it or widen it to receive more frequencies. Once you see something on the screen, you're able to narrow obviously the frequency band down, and therefore pinpoint the leak very accurately and get an exact signature of what frequency that's taking place at. Again, it's just about honing it in basically. So like most things, keep the level wider, and obviously you get more in there, and then you can start to finite it until you get much more levels of accuracy on there as well.
So it helps with precision.
Precision and accuracy, yes, exactly. And then obviously once you capture the information, you then pull that all the way through to reporting as well.
Great, thank you. So can you set up multiple profiles or users on the camera?
Yes, you can have profiles on there as well. That's not a problem at all. As regards to the customer, yes, it operates a very simplistic, create a folder for the images. So should you be one company, you might have 4 or 5 sections of the plant, or a QA area, or a test bay area, or a paint shop area, or a production plant. So each of those could be called a location. So every time you go into that area, then yes, you would save the images or the video to that location. And then obviously once you extract the images out, or the files, you put them through the software and they're automatically dropped into the relevant locations. So it's very simple and very straightforward then to keep a catalogue, or obviously folderize all those images for future reference.
Okay, so it's more advantageous for like data management sort of thing.
I would say so, yes, definitely, because you're able then to get any future ones and any past ones that you might need and obviously have them all in one locality.
Great. Okay. I think we touched on this a little bit earlier, but could you just clarify, are there any limitations in regards to the types of gases that it can detect?
Well, again, we touched on it very loosely earlier, and it's all about the density of gas. The lighter the gas, the more challenging it can become. Only because, as you can imagine, if that gas is very light and it comes through the leak at a very low pressure, it's going to disperse into the air very quickly and very easily.
Yeah.
And because of that, it means that the sensitivity of the unit, that gas might be too slight and the leak might be too slight to be able to detect that. So obviously that happens at very low end. We do have a chart that obviously highlights the difficulty of detecting those gases.
Where's that chart?
That chart is available on our website, so we can have that. So the gas there obviously has a chart that can do that. And then obviously what also happens is the pressure of the gases as well has a strong impact on that. The ii910 is capable of detecting low pressures, and it can even detect some vacuums if they're strong enough over a longer period of time. But again, it's all about the nature of the gas and the pressure that it's operating at.
Right. Again, this is another thing we've touched on, but if you could expand on it, could you explain what leak-Q is, what it can be used for, how it works?
Okay, right. Well, identifying the leak is one thing.
Yeah.
Finding a leak, positioning it, obviously getting an image of that is great. And if it's just to find the leaks, that's perfect. The next stage of evolution was that we started to quantify these leaks. People wanted to know, okay, we've got 10 leaks on here. What is the cost implication to us if we do nothing about those leaks and not putting them right? So we would go to a site, we'd find the leak, we'd put it, and then we'd quantify it. It's very simple. You would just position the unit, you'd aim it at the leak, a circle pops up on the back of the screen. Right. You target the leak that you've located within that. You take the image, and then within a few seconds, it's captured all that data, and it will to give you the severity of the leak from 1 to 10. It will give you a leak rate in litres per minute. It will give you an estimated cost based on the pressure and the gas that's there, and it will give you the distance you are from that leak as well to help obviously find the location and get additional information. And all that can then go to a report. So once you've done a number of those, and you've found a number of leaks and you've quantified them, you can say, okay, on that section of the plant there, we have X cost of leaks. And again, it would help prioritise them and obviously help to reduce the cost once you've fixed them as well.
Does that all take place on the camera, or do you have to input that online?
The information originally would come onto the unit itself. It's captured on the unit, and as long as you fill in the relevant information on the unit, yes, you would have that information readily available there. At the end of the session, or at the end of the day, or when you've finished the work that you're doing, you can capture this image and pull it to the PC, and then everything will obviously be able to be obtained through a report that you can then file away, present to management, or even put as part of your repair preventative maintenance plan.
And is there similar software for partial discharge and the mechanical detection?
They all work in the same way. They all capture the information on screen. For partial discharge, it will give you a pulse count of obviously the PD that's taking place, and it will identify potentially what type of partial discharge it is, whether it's corona or void, arcing, and it will also display the pulse count on screen for you as well. So somebody with experience at partial discharge could quite easily see what that signature represents. With mechanical quantification, same again. It works in 3 different modes. You have the first mode, which is a set 30 kilohertz frequency. You then have the option for the user to select his own one in mode 2. And then the third mode is multi-mode. So it does it at 4 different measurement points. So it can then scan. And the reason it does that is because talking with some bearing manufacturers, we know that these set frequencies are a leading indicator to where these faults are likely to start happening, basically. So if you're able to detect something on some bearings at those signatures, it's a good potential that there's a potential error fault likely to take place there as well. So it's just a frontline way of starting that investigation.
Thank you. Is there anything else you want us to know about the Fluke acoustic cameras?
Okay, well, I'd just like to reiterate, obviously, that it is the most intuitive unit out there at the moment. It's obviously, as you can see, it's a very robust unit. It's built well, constructed well, but it's very easy to use and gives you very clear information for the user.
And so if you were to sum it up in 3 words, what would they be?
Okay, intuitive, effective, and dependable.
Great, thank you. Thank you for your time. That was very informative. That's it for this episode. As ever, you can find all the information about our products, including the Fluke ii900 and ii910 acoustic imagers, on our website at www.tester.co.uk.